Great, it's super great to be here. I run a nonprofit, 501c3 in Brooklyn, New York, which looks at cities and how we could make them ecological. So it's kind of a research and think tank called Terreform ONE and Planetary ONE. One of the big projects we had to work on was we were asked by the city of Detroit to solve this, the issues of it shrinking, the issues of a kind of a dilapidated urban core. And we had to stand on the shoulders of probably some of the smartest minds in the world. There are about 30 years of architects, developers, planners thinking about Detroit and how you could solve its urban problems. So they gave us a modicum of cash, which is usually the case for architects, especially nonprofit ones. So we thought long and hard about what we could do with the city of Detroit, and we decided that this would be our kind of design solution. The idea would be to begin by changing the name, and it's actually something simple, so you don't have to reinvent the wheel. A lot of the things that we do are very complex, and so here are some ideas that we had for the city of Detroit, which is, this was produced by a leather-clad intern obsessed with KISS, and they actually liked it. And I think if you start there, you can begin change here, I guess at the branding level. Other projects that we had essentially made it to the cover of Popular Science. This was a big thing in my life because as a kid, I guess I've always loved Popular Science. They've always exaggerated the truth. So here I am on the cover, given the opportunity to, quote, change the culture there. But we looked at everything that makes up a city, from the doorknob to the democracy. So there are blimps that park into skyscrapers, new types of green technologies that build up the facades and fenestrations, new types of mobility systems, cars, jetpacks that affect the future city, and what does that research do and look like, and exactly what are those cities all about. So that's what we work on. At MIT, where I was doing my PhD, we did a project in the Smart Cities Lab. It was about the car of the future. Thought that was a little boring because cars of the future are, after 5 years get really old. So we decided to think of a lexicon of ideas that would fit into vehicles everywhere, kind of like the airbag. So here is the entire car in the wheel, drivetrain, suspension, motoring, all inside one particular wheel. You add 4 of them together and you get a car. And anything could be the body. So, this brought up a whole different set of relationships with the city. In fact, it really wasn't about the car. It was about fitting a system, a mobility system that would fit the city instead of cities designed around vehicles. So here's the stackable car. This was done under the late Bill Mitchell, but it is a kind of a very small footprint. It has an articulating frame, so it stands up. They interlock, so you can park about 300 of them on a New York City block, as opposed to 34. You can take the one in the middle of the stack. It's a drive-by-wire mechanism, kind of like a Facebook on wheels. So it gets you to where you want to go, and that's it. It's designed for a very specific context. That is the city. So it's a very different approach to cars. In fact, it's also mostly about parking. If I was some alien species looking at cars, I would think that because they don't move for 90% of the time, they were designed to just stay there. So we're thinking about changing that solution space. So after that, we had looked at articulating the wheels. It's not doing jumping jacks, but it can spin on a dime and rotate, and kind of a new way to explore the city. Or if everything is inside the wheel, we can change the skin to become this informatic space. Here you can kind of celebrate anything you would like through e-ink, etc. You can kind of send out a social projection. And you can also kind of change the quality of that surface. Here it's controlling an aperture point that opens up wherever the driver looks. The skin is incredibly soft. Everything is in the wheel, so it's a series of ETFE quilts within air bladders and starch foams that hold up the car. The car is as soft as possible. You pull them out of the stack and you get this kind of cluster of soft cars. And it's okay to rub up against your neighbor in this kind of a vehicle. In fact, that's kind of the point. Henry Ford was a big influence. He had done what we'd want to do. Here he is hitting an axe on one of his vehicles. It's made out of soy-based plastics. He wanted to merge America's grand agricultural economy with its automobile economy and grow the bodies of cars. We also had other solutions for thinking about how to make things soft. So we got involved with the sneaker company Reebok, and they became part of making the body of the car, so introducing the shoe car. It's got a very sexy zipper to get in and out of it. And this car, called the Hug and Kiss Lamb car. The idea of this vehicle is it doesn't go faster than 30 miles an hour. It's designed for downtown cores. It moves in a kind of gentle congestion. It rubs up against other vehicles. And the first principle is that no one will ever die in a car accident again. So how do we design a car from that perspective? And then how do you phase them into the city? Because there's always someone that's saying, what about those giant Hummers on the road? Well, you have all these intelligent, linked, soft cars kind of clustering around a Hummer. When it finds it, moves it off the streets as they kind of take over the city. And here's a smart car. The footprint that we were going for is a metric, 86 inches in length. Here's another version of our vehicle, same car, but this one, same length, sorry, but the two wheels come together and the vehicle stands up, so it's about 30% smaller than a Smart when parked. And this is when it didn't become so much about cars anymore. So actually, these are very big batteries on wheels, swarm lithium ion. And it actually became a new way to energize the city. It could absorb peak demand and redistribute load on the fly. These are very big batteries on wheels that are ubiquitously planted throughout the entire urbanscape. So it's a very different notion about thinking about just cars. You can integrate it with mobility systems. And then other forms of power, in this case, fat. So this is called the human-powered river gym. As you work out, it kind of harnesses that energy. It trickles down to the drivetrain, and you move over the water, I guess, on a commute to work. And then another, this is what we call the blimp bumper bus. The idea here is that to preserve the fantasy of the Macy's Thanksgiving Day Parade, but have it every day. So these giant blimps kind of move in soft herds very slowly with ski lift-like chairs, and you hop on and hop off, after about 40 blocks or so. And then all these systems in kind of this relationship called smart dots and soft mobs, and rethinking streets so they would absolutely be as green and ecological as possible. But it's important to privilege probably the best form of mobility in a city, and that's what I did here in Rome, is I walk. And I think that you want to create places where people are more than welcome to be pedestrians. And if not pedestrians, certainly bicyclists. Also thinking about other concepts like jetpacks. It's not unreal to think about when we're going to get jetpacks. I don't know how many people want a jetpack, but pretty much I think everyone wants to get there. We've been talking about them for 50 years. You can buy one for about $100,000. Martin Jetpack does purchase them. It's about making them incredibly safe and looking at their relationship to the city. We've done the same thing. So here are some of our designs. These also move in flocks and herds. They're incredibly soft. Same kind of air-quilted air bladder system on the exterior. The only way to describe how they move, they're powered by hydrogen peroxide, is a kind of like a and they float, and then and they can bounce into one another and chow, and you say hi, it's okay. And you get to your destination rather quickly. In fact, in about a matter of minutes from Newark, New Jersey to downtown Wall Street, as opposed to taking about an half hour in an SUV and then another half hour for parking. And they move in clusters to go longer distances. And if you're not into jetpacks, you might be into something, what this is called a new sport on the cover of Aerospace magazine, cluster ballooning. It is fabulous. It's certainly the same thing without any kind of fuel whatsoever. So you just use the wind, although control mechanisms are not quite there yet. And then another project we've been working on is thinking about the absolute green version of the suburbs or the peri-urban conditions. Here we have taking a technology that's 2,500 years old. It's called pleaching, or grafting inoculate matter to form one contiguous vascular system in trees or woody plants. It does take a bit of time. This project is called the Fab Trehab. It is the landscape. It is a part of the metabolism of its ecosystem. The outside is the outside, and the inside could be anything you'd want, but it welcomes all those fun things like butterflies and squirrels and bugs and things that not all bugs eat trees, by the way. I think there's always someone that's talking about if my house gets eaten. We've been doing research on what eats homes, etc., or trees. It's solvable, a little modicum of maintenance. And all you need is time, and you can grow a village for 1,000 families that is made with a piece of nature. A lot of people have a problem with that issue of time. There's this kind of culture of immediacy and affluenza. I need it now. We wait, 12 years for a bottle of scotch. I think we can wait 5 to 10 years for an entire village that fits into the environment. This is the model showing it growing in elevation, etc. And then the last project, because I was told that there was an issue of waste management in Naples, to talk a little bit about trash in cities. So here's where I start. This is a project that was involved with Disney Imagineering. I'm absolutely in love with WALL-E. If you haven't seen the movie WALL-E, it's fantastic. My 2-year-old daughter, actually 2.5-year-old daughter, loves WALL-E. He's this nonstop, affable robot that's solar-powered, building like Nebuchadnezzar these ziggurats all day long for thousands of years, and he builds them out of trash. And I thought, well, let's look at recycling or upcycling waste and a kind of a future perspective as a new theory for a city. So one of the projects that starts at the kind of the smaller scale, I was asked to go to Frankfurt and take e-waste, massive amounts of e-waste, more than enough to fill up this room, and upcycle them to another purpose. So I got off the plane, had no idea what I was going to do, so I said, robots, let's make e-waste robots, and they will signal certain areas, we'll put them in the city, they'll signal certain areas that are good or bad about the city. So we started making these funky robots. We actually kind of put the funk in functionalism out of all these different components that you would find in washing machines and toasters and whatever was there. And we did zillions of them, and they all, some of I thought they were super cool. Some of them look a bit violent, but they're not. They're just robots. And put them throughout the city, got people's reactions, which was pretty cool. We made one that was about 35 feet tall. So this was one example. Lights up at night. There was some big music festival going on. Here they are in front of the museum, or there's another set of them. Had about 5 days, so I made about 7 of these robots. Here they are in the square in Darmstadt, and this is kind of this funny picture where the can't write this up, but they immediately, the Germans. There are Germans here, very neat people, orderly, came to inspect and maybe are they waste or not. Actually, we invited these guys, the waste management guys, to the opening. They showed up dressed like that. They were very cool. And then different devices that are off the shelf that you can use to modify trash. So these things make big, dumb blocks, bales of trash with no geometry. If you modified their jaws ever so slightly, they can make puzzle-fitting geometries. So we started looking at cities that would be made up of this kind of material. So here is a architectural folly showing 1 hour of trash in the city of New York. 38,000 tons of trash per day is produced. Here is just 1 hour of that, basically larger than the Statue of Liberty. We made a model for the MoMA showing the Statue of Liberty in it. And then what is 24 hours of trash in the city of New York? Well, it's a 53-story skyscraper. And we thought of how would you actually make some of those components by modifying those jaws and dealing with the organic and the inorganic elements simultaneously. So we have a mycoform brick. A lot of the work that we do is in cell biology. There's a meat house project for another time. I'll tell you about it. But essentially, we looked at growing bricks from the waste you'd find in landfills, find cellulosic structure. You grow it into essentially, into a mushroom that dies, and you get a brick form. And you could use inorganic systems like aluminum, which has a high embodied energy, which doesn't go anywhere for thousands of years, constantly cycling it. You can make a perfect brick. So here's the brick, part mushroom, part aluminum, as one example, grown from what you find in landfills. And here is our processing of the strains in the lab, if it'll go. Yep. So 7 days, you can see mycelial propagation. You can go from just a teeny bit of food into an entire petri dish filled up with this very rigid-like structure. A company, Ecovative, actually is invested in doing this to make products for insulation. Combine it with just a hydraulic press, handheld if you would like, and you get that particular brick. We've been making all different geometries out of this mushroom. In this case, here's our 3D petri dishes. We made square mushrooms that were Tetris-shaped, that interlock, etc. So here they are in the incubator, working out. And here's what we did for the Museum of Contemporary Art, making a square mushroom in 7 days in this stop-motion film. We projected it on the surface of the museum, but you could see that all of the cellulosic structure, the kind of the dirt and wood chips, disappears as the mushrooms overtake it in 7 days, breaks the mold. You got a very solid, it's actually this big square mushroom. Good for building. So here we are making a proposal for a 53-story skyscraper made out of the same material, combined with the aluminum brick, jetpack ports for getting in and out, of course, because it's a future skyscraper. And then I'm faster than the slides. And then finally, the last two images, we were on the cover of Architect Magazine. This is our reification of a future city where waste has gone away. In fact, there is no such thing as a way. Gertrude Stein said it best. You just don't throw something out and it's magically gone. It's always here. So we thought of a society that moves out of the age of consumerism and industrialization into an age of beginning to retrofit our buildings with our waste products. In fact, waste is actually just a new form of creativity. Employ many designers to recreate and upscale that waste, until eventually that landfill, which is the kind of the large black underneath it, all of that 38,000 tons goes away and becomes part of the city, where you have a future city where there is no waste whatsoever. Instead, it's a city that moves from creation to creation to creation. That's my work for now. Thanks very much. Love Rome.